Hi everyone, this is Duke with an introductory video for a new series, I guess. I'm getting to be more of a YouTuber now, I guess. But I decided to break up the video, in this case for my class, into a couple different parts. So there'll be a build series or a playlist or whatever you want to call it. And this is the first in that series. What we're going to do in class in the spring of 2026 is we're going to build a Arducopter vehicle of this type. Okay, so like this. This is the Speedybee35 uh, frame, so it's a 3.5-inch diameter prop size. It's kind of meant to be like a Cinewhoop type build. We're going to use it for ArduPilot, and I have moved away from my other frame. If you've seen in the past, the X500s, the larger frame, for a number of reasons, for cost, portability, and then also, just so happened that recently we have a lot of difficulty getting Holy Bro equipment in the United States. So we're doing a different build this time. I'm pretty excited about it. I've flown this one already. It seems to fly just fine. I can get enough flight time out of it for doing autonomous flights in a later class, and so it kind of fits the bill for right now anyways. And so this video is meant to introduce the hardware to you, so the pieces you'll be getting from class, and then some of the stuff you'll need to buy. And then the subsequent videos, I'll go over a little bit of the software. Then we'll come back to the physical construction of the quadcopter. Then we'll go back to the software, configure the quadcopter, and then we'll go and fly it. And so it should be about 5 videos, I think, in this, and walking you through some of these processes. And for some of the videos, I also have a written document that corresponds to what we're going to do in terms of steps and things like that. So here we go. These are the materials you will receive as part of the class. You'll get these with your course fee. And with the exception of you won't get 2 flight controllers, I'm just showing you 2 different packaging options here. We'll kind of go over these bits and pieces one by one here. Okay, so the first thing, the Speedybee35 frame. This is again a 35, kind of corresponds to the 3.5-inch propeller size that we're going to be using that fits in these ducts here. So this is the injection molded kind of duct subframe, if you want to call it that, I guess. And then we have our carbon fiber mainframe that kind of sits more or less like that on the frame. If you didn't notice already, this is a pusher style aircraft, so the props are facing down, or if you want to think of it that way. Everything else is on top, battery and stuff like that. The flight controller is kind of tucked in between this bottom plate and the top plate here, so there's an area in the center we'll look at as for the flight controller and stuff goes. Okay. But in this frame, we have again, carbon fiber, an injection molded plastic type piece here. And then we have a few 3D printed pieces, which are kind of cool. Some of those are pretty useful. Some of them we won't use, so that's okay. We also have some CNC aluminum mounts for like a camera, like FPV style camera. We're not going to do FPV in this class, so you save those if you want to add FPV later, but that's kind of an extra piece for us. A bunch of other screws and hardware. Speedybee does a pretty good job labeling their hardware and things like that. Okay. We have a battery mount, battery strap, and then we have this bottom plate piece. And so I want to point this out. This is the Speedybee35 normal frame I have right here, whereas this one I have built is the Speedybee35 Pro frame, which I actually bought by accident. But the main difference between the 2 frames, as far as I can tell, the only difference is that the Pro frame has an aluminum CNC bottom plate here, and the normal version just has a carbon fiber bottom plate. Okay. Now, this is more designed for a digital video transmitter to fit down here, be a kind of a heat sink and that kind of thing. We're not using a video transmitter at all, so it's just kind of an empty extra space there. I actually used it for the LED control board. But some of you will receive the regular frame, some of you will receive the Pro frame. I couldn't get enough of the frames to have them all be the same kind. So we just have some of one, some of the other. It doesn't really matter. They're like a couple of dollars difference. And for what we're doing in classes, it doesn't matter at all. But just be aware you may receive the regular frame, you may receive the Pro frame. This is how it went this semester with trying to source parts and stuff. Okay, so that's our bottom plate there, carbon fiber bottom plate. And Speedybee has their little QR code here for the manual, which you'll probably want to take a look at. It helps you assemble the frame and things like that. I'll also talk about that in the video a little bit later as well, or in a later video. But don't lose the QR code. Of course, you look it up on their website if you misplace the QR code. Okay, so that's the frame piece there of our build this semester. I'm going to slide this down below a little bit. I'm pretty excited about it. I've flown the other one already that's already built. Seems to fly pretty well. We're not doing a lot of acrobatic flying with ArduPilot in class, but I got it to hover for about 10 minutes on a larger battery, which is long enough to do autonomous flights and stuff. And that's kind of the goal of the platform being available for this class, where we can do things like loiter flight mode and GPS assisted flight. And then there's another class that follows this one. If you choose to take that, we go deeper into mission planning, autonomous flight, added some extra sensors and things onto the aircraft and that sort of thing. The LEDs are kind of fun too. That's something we add later in the other class. So there's the quadcopter and the frame. Okay. Going into the frame or onto the frame, we will have 4 motors. Okay. These are Emax, let's see here, 2004 3000 kV motors. The 2004 refers to the size, and then we have the kV right there, refers to roughly the RPM, I guess you could say. So we have 4 of those motors, and those are the same ones I have on here. They work pretty well. I like them so far. And then, of course, going with the motors, you have your propellers, 3.5-inch propellers, and so you may get a different color, but 3.5 by 20, or sorry, 3.5 inch in diameter by 2-inch pitch propellers is what we're using in class, unless I find another option before we actually start class in the spring. So we'll have those as well, along with our motors. And then we'll have a GPS module. This will allow us to do things like loiter flight mode, GPS assisted flight. Now we're using the Walksnail M181 GPS module this semester. I have one of these on my aircraft and it works quite well in my experience so far. So we'll be using those. They seem to work pretty well, get a lot of satellites, pretty fast fix, GPS lock. So I like these ones for class. So we'll have that. And then last but not least, we'll have a flight controller / ESC. Okay, so there's just 2 different packages. So you might receive this package, you might receive this package. They're the same thing. They just change their packaging. And so I guess I turn it this way. If we take a look at this, it is the MicoAir H743 all-in-one flight controller. This is the V1 flight controller we're using this semester. They do have a V2 out, but we're using the V1 this semester, which is also what I have in here. Okay, works quite well. I like that they include a SD card, and then this is an H7 flight controller, so we can do cool stuff like Lewis scripting in the later class. But for this class, we're focusing on just getting the thing built and flying. And so you can see here, it's a flight controller combined with an ESC. And so we have our USB port here for communicating with the flight controller, and then we have, for example, our larger battery connection pads here, and then we have the groups of 3 pads around the edges of the flight controller ESC to connect our motors to. And then on the bottom, we have a little section of pads here, as well as these different plugs around the board, okay, to access our peripheral or to connect our peripheral devices like our receiver, for example, or GPS. So some of them can be done via the connector, some can be done via soldering, and that's in essence the brains and brawn of the drone combined into one board. And you can see here they just have the exact same thing here. It's just packaged a little bit differently. In either one of them, you're going to get all the wiring and stuff you might need. And so if we pull up this little foam here, we have a set of wiring harnesses, which we may not use all of these, but they're all there for you. Then you have a capacitor, and you have a battery lead. Okay. With the type of flying we're doing with this, we'll probably want an XT60 instead of an XT30, just because the batteries that we want to use are a bit bigger, and they typically come in XT60 sizes. So you can decide if you want to swap out the connector on the drone or do some kind of adapter for your batteries or however you want to do that. But they do give you a battery connector there, which should get you everything you basically need to get this flying in terms of hardware. Okay, so that is the kind of rundown of the basic parts we're going to be receiving this semester. So your flight controller, 4 motors, propellers, GPS, and frame. And so that's all the stuff you'll get as part of class, part of your course fee. That's already paid when you get to class, basically. And then there are 2 pieces of equipment that you'll need to bring yourself to class. This will be part of your textbook items, and that is a receiver and a transmitter. Let me get the transmitter out here. Okay. Again, I use Express LRS on everything. In my opinion, it's the best, but some of you may have a different transmitter receiver setup. That's fine. Here we have a TX12. You can buy TX12. You can buy Radio Master Pocket. There's some resources on the Canvas class page about like which transmitter to buy and that kind of thing. But you basically want to make sure you have a transmitter and you have a receiver that work together and will work on the aircraft. So in this case, it's just an Express LRS Edge TX radio transmitter. Works great, lots of different models there. You might have one from another class already, and that's fine. As far as the receiver goes, you'll want to source a smaller receiver. You don't want to buy a PWM receiver or something from an airplane for this class, because we need to be able to tuck it into the drone's frame. So it's got to be relatively small. There are some receivers out there that have a ceramic antenna. You can see this little kind of tower thing sticking up here. That would probably work fine for the distances we're flying, and we're not flying super far away with these. But if you have the choice, I would recommend a receiver that has an external antenna that clips on like this, okay? And that antenna can then be routed out of the kind of middle of the frame. And you can see they include a little 3D print thing here that's meant to kind of hold an antenna. And so I have my antenna sticking out there. It looks pretty good, works pretty well, I think. And so that would be my recommendation, to get at least a receiver with an external antenna of some type that you can route outside the frame. Again, I'll use ExpressLRS and all the setup and stuff like that. If you happen to be using a different protocol that supports different receivers, just try to get one that's small enough to fit in the frame. And then you want to get a receiver that supports serial communication. You don't want a PWM receiver. So if we open this one up here, if you're looking for serial receivers, ExpressLRS has got a lot of those, but some other brands and protocols do as well. And kind of the giveaway, I guess, or the clue on those, if you're kind of new to this and not sure what you're looking for, typically a serial receiver will have 4 pads, and they're often marked. It's very hard to see the marking probably on camera, but they're labeled, and we should have a power pad, a ground pad, an RX pad, and a TX pad. So that allows you to power the receiver with power and ground, and then have it communicate with the flight controller with a serial connection to a UART. If you have questions about that, please let me know. But just don't buy a receiver that is a PWM receiver. You can reconfigure some of those to use SBus, like a serial protocol, but it's going to be kind of big to fit inside the actual airframe. So I'd recommend against doing that unless you absolutely have to. And if you want to just have a challenge, I guess, of trying to fit it inside the frame and stuff, that's fine too. But I would recommend getting a serial receiver along with a transmitter that have the same protocol, so speak the same language, in this case ExpressLRS, is a good option there. All right, so that should take care of all the bits and pieces for your build this semester. And again, make sure you are able to get those things you need before class. Let me know if you have any questions, and we'll see you in the next video.